Okay, in this presentation we're going to work with moment generating functions, essentially. That's what this one's really about. Just a sort of quick exercise to get used to them. Consider the discrete random variable x with the probability function f of x equals 4 over 5 to the x plus 1 for x equal to 0, 1, 2, all the way up to infinity. Show that the moment generating function of the distribution of x is given by this expression here. Mx of t equals 4 times 5 minus e to the t to the minus 1. Actually, you might also write that as 4 over 5 minus e to the t. For t, e to the t less than 5, okay? So, there's a sort of reason for that we'll come up with shortly. Determine the expected value of x, e of x, using the moment generating function used in part A. So this is the definition of the moment generating function. So this is the sort of the key thing to start off with here, okay? So essentially what we have here is e, the expected value of the exponential of t times x, okay? So that's the sort of key part there. Now, just actually with a lot of these videos, particularly with something very mathematical about them, or, well, obviously mathematical, but there's some sort of derivation, it's good to keep in mind a lot of fundamental mathematical theorems and definitions and so on. One we're going to use in this particular video is the geometrical series, the summation of a geometric series, okay? So this is something you probably should have encountered before, but essentially just the summation of this expression here, or which is the summation of each consecutive power of x, x2, x3, x to the power 2, x to the power 3, and so on, can be written as 1 over 1 minus x, which is valid for x less than 1. Okay, so we'll just sort of keep that in mind for later on. So our probability mass function here is 4 over 5 times x to x plus 1. Now, I'm going to rewrite that as 4 over 5 times 1 over x to the power of 5. Essentially what I want to do here is get out a constant term and remove it just to sort of simplify the expression as much as possible. And also just to actually have break it up into two simple expressions as much as possible. So if I was to decompose that, 4 over 5 and 1 over 5 to the power of x is probably the simplest way to decompose it, essentially. It's a sort of informed decision, okay? So, anyway, let's get stuck into it. So, the moment generating function, okay, has this definition here. Now, it's the expected value of tx, okay, e to the tx, okay? So, essentially what we're going to do here is to write out our expected value. So, each specific outcome of e to the tx, there is e to the t0, e to the t times 1, e to the t 2t, and so on, times the probability of that x value there, which is 4 over 5 times 1 over 5x, okay? Now, you sort of see what I'm doing here. I can actually sort of factor this out, bring this outside, okay? And I can combine this expression here with this expression here. It's both, in both instances, it's something to the power of x, okay? So it's e to the t, the power of x, times 1 over 5 to the power of x. So I can make that e to the t over 5 to the power of x. Oops. Okay, does that make sense? So that sort of justifies this expression here earlier on. So my moment generating function can be written as that. Now this is where the 5 e to the t is less than 5. That's now becomes important here, okay, because this means it's less than 1, okay? So where was I here? So that part there, okay, that's why this is important now, because it's this is valid for x less than 1, the absolute value of x less than 1. Okay? So that means this whole expression here has to be less than 1. Okay? And that only works if that is the case. So, anyway, that just sort of helps us. It sort of gives us an indication. Actually, it's a subtle hint after the fact, now that you realize it, that you're going to be using the geometric series formula, summation formula. So, there we go. Actually, in this case, what we have here is, it is 4 over 5 times 1 over 1 minus e to the t over 5. And if we just sort of rework that expression, we get 4 over 5 minus e to the t. Now that actually is our moment generating function there. And that's really the answer we're looking for the first part of this question. Okay. So that's actually part A. And part B is as follows. Find the mean of it. Okay. Find the expected value. So we're going to get the derivative of the moment generation function and then evaluate it at 0. Okay, so that's all we have to do. It's a short enough one. So essentially, get the derivative of this. Okay, which is this. Okay, now just as a quick like e4 over 5 minus e to the t minus 2 squared times e to the t. Just actually watch out. Essentially, what I'm getting at here is the chain rule when you do the differentiation there. Okay, so that's how we end up at this. Okay, so as I sort of said before, in a lot of these instances, like simple stuff like the geometric sum, geometric series summation, and chain rule, and all those fundamental mathematical equations and definitions and algorithms always come into play. Okay, so essentially that is the derivative of the moment generation function there, which can also be written like that. Okay, now essentially what we have to do is evaluate it at 0, and there we get the expected value is 4 times e to the 0, which is 1, times 5 minus e to the 0 to the power of minus 2. Okay, so that's 4 times 1 over 5 minus 1 squared. That means our expected value there is 1/4. So that's it. That is a moment generating function calculation there.